Watch a semi-truck long enough, and you'll eventually catch something that looks like a mistake. A set of wheels hanging in the air, spinning slowly, or not at all. Not touching the road at all. It looks broken. It looks like the driver forgot something. It is neither. That axle is lifted on purpose by a driver who is doing math. Because in American trucking, every axle you put on the ground is a decision that costs money, changes what you're legally allowed to carry, and can be the difference between a legal load and a fine at the next weigh station. By the end of this video, you'll know why trucks have wildly different numbers of axles, the federal formula that quietly shapes every truck on the road, why lifting wheels saves thousands of dollars a year, and the strange reason that a heavier truck is sometimes better for the road than a lighter one. Let's get into it. Start with the thing everyone gets backwards. People assume more axles means the truck is heavier. It's closer to the opposite. More axles means the weight is being spread thinner. Think about walking across fresh snow. In boots, you sink. On snowshoes, same body weight, you float. Nothing changed except how many square inches we're carrying. Roads work the same way. Pavement doesn't primarily fail from total weight passing over it. It fails from concentrated pressure, hammering the same spot again and again. Engineers found that the damage a vehicle does to a road climbs dramatically as the weight on a single axle increases. Doubling the load on one axle doesn't double the damage, it multiplies it far beyond that, which creates the central tension of trucking. The trucking company wants to move as much freight per trip as possible. The state wants its highway to survive. Both wants are legitimate. So America wrote a compromise into law, and that compromise is the reason trucks look the way they do. On interstate highways, U.S. trucks generally operate under a maximum gross weight of 80,000 pounds. That number is famous. But the number alone doesn't control anything, because 80,000 pounds sitting on 3 axles is a completely different object than 80,000 pounds spread across 5. So federal law adds a second rule known as the bridge formula. In plain English, it says, the more weight you want to carry, the more axles you need, and the farther apart those axles need to be spaced. Why spacing? Because of bridges. Literally, a bridge span carries load across its length. Concentrating heavy axles close together puts the entire load on one small section of the span at once. Spreading them out means the bridge feels the weight arriving gradually, more like a wave than a punch. This single rule explains almost every truck design you see. The classic American 18-wheeler, 5 axles, 18 tires, is not a random configuration. It is the shape that emerged as the efficient answer to that formula. The most legal payload with the fewest axles. Then look at heavy haulers, the trucks carrying transformers, excavators, factory equipment. They sprout extra axles like insect legs, sometimes 8, 10 or more, often on stretched trailers. Those trucks are usually running under special permits, and every additional axle is buying them legal capacity by spreading pressure further. And look at the small end. A dump truck or concrete mixer working in a city runs a compact frame with axles bunched close together because it needs to maneuver tight streets. That compactness costs it capacity under the same formula. Its shape is the price of its job. Now we can finally explain the floating wheels. Many trucks carry what's called a lift axle, sometimes a drop axle or tag axle, mounted on airbags so the driver can raise or lower it with a switch in the cab. When the truck is loaded heavy, the axle goes down and starts carrying its share. When the truck is empty or lightly loaded, the axle goes up. And here's the payoff. Tires that aren't touching the road, aren't wearing out, aren't creating rolling resistance, and aren't burning fuel. Truck tires are expensive. Multiply that across a fleet and a lifetime of miles, and lifting unused axles becomes real money. Fuel savings, tire savings, and less brake wear. There's a second reason, and it surprises people: turning. Every axle on the ground resists a turn, scrubbing sideways against the pavement. A truck maneuvering in a tight yard with all axles down fights itself. Lift one, and the truck turns easier and scrubs less rubber off its tires. And there's a rule with teeth attached. In many jurisdictions, lifting an axle while loaded heavy is exactly the kind of thing weigh stations look for, because it shifts weight onto the remaining axles and can push them over the legal per-axle limit. The axle is a tool, not a loophole. Up when light, down when heavy. Which raises a question that flips everything you assume about heavy vehicles. Here's the counterintuitive part. Imagine a load of freight that has to move. Option 1. One truck with fewer axles, running at its per-axle limit. Option 2. One truck with more axles, spreading the same freight thinner. The second truck weighs more. It has more equipment on it. Yet it may be gentler on the pavement because the pressure at each contact point is lower. Total weight isn't the enemy. Concentration is. This is why some states allow higher gross weights specifically for vehicles with additional axles, and why the trucking debate about weight limits is never as simple as heavier trucks destroy roads. The honest version is, how the weight is distributed matters as much as how much of it there is. It also explains a detail you may have noticed at weigh stations. Scales that measure each axle group separately. A truck can be perfectly legal on total weight and still be shut down because one group is overloaded. Usually because the freight inside the trailer was loaded too far forward or too far back, which is why you'll see drivers sliding the rear wheels of a trailer forward and backward in a truck stop. They're not fixing anything, they're rebalancing. Moving the wheels changes how much of the load rests on the trailer versus the tractor. It's weight distribution by geometry, done with a pin and a parking brake. Now you can read the road. 5 axles, 18 wheels, long trailer. The standard American freight hauler, engineered around the federal formula. 3 axles, short and stubby, wheels close together. A local vehicle, dump truck, mixer, garbage truck, trading capacity for maneuverability. A trailer with wheels spread far apart, extra axles, oversized banners and escort vehicles, a permitted heavy haul, and every one of those axles exists so a bridge somewhere doesn't feel that load all at once. An axle floating in the air, an empty or light truck saving fuel and rubber, and one bonus detail, the trailer wheels you see sitting far forward or far back on the rails. That's not a design difference. That's the same trailer, adjusted, because somewhere behind those doors the freight is sitting where it sits, and the wheels came to meet it. So a semi-truck isn't just a big vehicle. It's a rolling solution to a math problem. How do you move as much as possible without destroying the road underneath you? Every axle is an answer. Every lifted wheel is an optimization. And every weigh station is the country checking your work. And while you're looking at those wheels, have you noticed that almost every position runs 2 tires side by side instead of 1? There's a genuinely clever safety reason for that. And it changes what happens when a tire fails at 70 miles an hour. I broke it down in this video right here. Thanks for watching, and count the axles next time.